Hey, how you doing out there in concrete land? My name is Dr. John Belkowitz. I'm the Director of R&D at Intelligent Concrete. So we're talking about equivalent alkali content. And you know, the reason why we care about that is because of something called alkali-silica reactivity. If it wasn't for alkali-silica reactivity, this would be a boring conversation. But the fact that alkali-silica reactivity has become, or ASR, has become so much more prevalent, ding! Here's a photo of it, and as you can see, the concrete itself is swelling because of this alkali-silica gel that's being created within the concrete. So that's why we care about this stuff, because it's this alkali content, the potassium and the sodium, that attacks the reactive aggregate, your sand, your rock, and your fines, and creates that expansive gel. So again, that's why we care about it. Why do we have a lot of alkalis in our concrete? Alkalis can come from a lot of different places. When we use supplementary cementitious materials or just ordinary Portland cement, they bring their own alkali content to the concrete environment. And it's not just the alkalis, it's a combination of moisture and alkalis, but if you can reduce your alkali content, you're taking away that mechanism that creates that pessimism or that environment for that ASR gel to thrive and survive. And there's some really smart people out there who publish a lot of great papers that are great to use in our industry, not just for the academic read, but they give you important information. So if you are a concrete provider, there are some great stipulations that are published here that are taken from all over the world that go over the maximum amount of alkalis that you can have in your separate materials and then your made concrete. And if you do, they even give you references on what to do with that concrete. So one of the things that we wanted to do is cover one of the equations that are published in the industry that allows you to take the chemical composition provided by your distributor for your cement, your ash, your slag, the binder matrix of your concrete, and chug it through this equation that gives you a sodium equivalent alkali content, and with that of your cementitious materials that are going to be used for your concrete, and with that information, then you can determine your weight per cubic yard or per cubic meter of your alkalis. And from there, there's all these standards. One of them was the CSA 823.1 that cautions, published in 2004, that cautions that restricting alkali content to 3 kilograms per cubic meter or 5 pounds per cubic yard might not be an effective strategy, however, and then it goes on. So it gives you not only the information about where you want your limitations to be, but what happens when you exceed those limitations. So a great CSA, and then you can also look at CSA 823.2-27A, alkali aggregate reaction. So some great information out there. And then don't forget our book, ABCs of ASR. Chapter or letter E is equivalent alkali content. So it's a great read, gives you a lot of overhead bird's eye view information as well as this equation. So let us know if you have any questions, any concrete concerns. Don't forget to like, subscribe, all that jazz. Go concrete, beat asphalt.